Hi all, very happy evening. Let us straight away get into a divisibility theorem. Morning I discussed just the concept. I will discuss all the problems with respect to the divisibility theorem. Listen carefully, sir. Divisibility theorem. For example, 17 is getting divided by 5. 5 3s are 15. Remainder is 2. Remainder is 2. 17 is nothing but the dividend. 17 is called the dividend. The number which is getting divided, the number which is getting divided, number which is getting divided, number which is getting divided is called the dividend. Number which is getting divided is called the dividend. 17 is called the dividend. 5 is called the divisor. 5 is called the divisor. What do you mean by a divisor? Number which is dividing dividend. Number which is dividing the dividend. Number which is dividing the dividend. That is called divisor. Divisor. 3. How many times 5 will go in 17? Maximum 3 times it will go. So 5 is nothing but the quotient. What is left over? Which is called the remainder. Which is called the remainder. So divisibility theorem states 17 is nothing but 5 3s are 15 plus something else is pending, that is 2. 17 is 5 into 3 plus 2. 17 is called as the dividend. 17 is called as the dividend. 5 is called as the divisor. 3 is called as the quotient. Plus 2 is called as the remainder. 2 is called as the remainder. Morning we discussed, now entire application I will discuss onto this concept. This concept is extremely important to do some advanced level problems in base system which is of cat level and also little up above the cat level. Dividend is nothing but divisor into quotient plus remainder. This is called the dividend. This is called the divisor. This is called the quotient and this is called the remainder. Dividend equivalent to divisor into quotient plus remainder. This is nothing but the divisibility theorem. Divisibility theorem says dividend is nothing but divisor into quotient plus remainder. Dividend is divisor into quotient plus remainder. Few important key points. Few important key points. If n is the dividend, d is the divisor, q is the quotient, r is the remainder. R is the remainder. For example, if a remainder I got 3, for example, if I get a remainder 3, when you divide a number by, suppose, if I divide a number by 3, what are all the reminders I will get? Reminders I will get 0, 1 and 2. Am I right? When you divide a number by 5, when you divide a number by 5, what are all the reminders you will get? 0, 1, 2, 3, 4. That means if I got the remainder as 3, if I got the remainder as 3, that means the divisor value will be greater than or equivalent to 4. It cannot be 3. Why it cannot be 3? If a number is getting divided by 3, what are all the reminders I will get? 0, 1 or 2. When you divide by a number by 3, remainder 3 is not possible. Remainder 0 is possible. If a remainder is 3, that means divisor is greater than or equivalent to 4. Why? Because if it is less than 3, if you divide a number by 1, remainder 3 not possible. If you divide a number by 2, remainder 3 not possible. If you divide a number by 0, that itself is not possible. 0 out, 1 out, 2 out. 3 is not possible. When you divide a number by 3, remainder 3 is not possible. So the only possibility is D is greater than or equivalent to 4. Similarly, if a remainder is 5, if a remainder is 5, that says that a divisor cannot take any value less than or equivalent to 5, or in other words, D is greater than or equivalent to 6. D is greater than or equivalent to 6. Each and every key point, whatever I am mentioning it, write down in your notebook, because if you miss out this key point, you might take more time to solve a quantitative aptitude question. I hope it is clear. Suppose, in other words, if the divisor is 7, when you divide a number by 7, what are all the remainders possible? It could be 0, 1, 2, 3, 4, 5 and 6. If divisor is 7, if you divide a number by 7, I will get any 7 reminders, that is from 0 to 6. Suppose if divisor is 5, if you divide a number by 5, what are all the reminders that are possible? 0, 1, 2, 3 and 4. 3 and 4. I hope this point is clear. If a divisor is given, you can find out all the possible reminders. If a remainder is given, you can find all the possible divisors. Divisor is the number which is dividing the given number. R is nothing but a remainder. Remainder is nothing but remaining. Remaining is nothing but what is left over. Right? So, R and D. This important concept is clear, right? Another thing. Another important point. This is the first important key point. Second important key point. If Q is 0, what do you mean by Q is 0? Q is 0 is quotient is 0. If quotient is 0, that means no division happened. Quotient cannot be 0. Quotient cannot be 0. If the quotient is 0, that means there is no division that has happened. Quotient value should always be greater than or equivalent to 1. Quotient cannot be 0. If the quotient is 0, that means division has not happened. Most of the times a teacher will just tell you dividend is a divisor into quotient plus remainder. Anyway, this value is given. If you know this, you can find this. If you know this, you can find this. If you both know this, you can find this. Quotient cannot be 0. Quotient cannot be 0. Quotient cannot be 0. Are you all with me? Right? This is another important observation. Next one. Let us solve one by one question. All the problems are based on division theorem. Then we will get into the advanced level. Start from basics and go to the advanced level. Solution. First we will go very slowly. Find the largest integer. Largest integer less than 40. N is the largest integer. N is the largest integer. This has to be less than 40. First condition. This largest integer is n. When you divide a number by 7, I am dividing by a number by 7. Quotient I don't know, so which is q. When you divide a number by 7, I got a remainder 2. I got a remainder 2. I hope it is clear. There is a number. When you are dividing a number by 7, you are getting a remainder 2. We know according to division theorem, dividend is nothing but divisor into quotient plus remainder. 7q plus 2. 7q plus 2, there is a restriction that must be less than 40. 7q is nothing but less than 38. Q is nothing but less than 5 point something. For n to be largest, if n is largest, this is a positive value, this is a positive value, this is positive sign. If n has to be maximum, q also should be maximum, because the equation is n equivalent to 7q plus 2. What is the maximum integer just less than 5 point something? Q maximum is 5. Q maximum is 5. Quotient is always an integer. Quotient is always an integer. quotient is always an integer. So it cannot be 5 point something. Q maximum is 5. So the form of the number is n is 7q plus 2. 7 5s are 35. 35 plus 2. Answer is 37. Answer is 37. First one, answer is 37. What is important to me is not the answer to this question, and the various applications of the division theorem is important. Second time I am explaining. There is a number n which is divided by 7. I don't know the quotient, but I know the remainder as 2. So dividend equivalent to divisor into quotient plus remainder. 7q plus 2. It is less than 40. 7q is less than 38. Q is less than 5 point something. Q is quotient. Quotient should be an integer. Integer just less than 5 point something is 5. Q maximum is 5. 7 5s are 35 plus 2, 37. Answer for the first question is 37. Now I will change this question. This is where if the question is smallest integer, if the question is smallest integer, there is a number n, n is divided by 7, quotient is q, remainder is 2, dividend equivalent to divisor into quotient plus remainder, n is 7q plus 2. Now that is exactly the reason I said most of the students will take it as q value 0. What do you mean by q value 0? Q value 0 means no division is happening. No division is happening. Lowest means they will substitute q0. No division is happening. But it is clearly mentioned in the question that it is divided by. That means division has happened. So q cannot be 0. Q has to be 1. So n minimum value will be 7 plus 2, it is 9. The smallest integer which when divided by 7 gives a remainder 2 is not 0 but 9. Q cannot be 0. If q is 0, that means quotient is 0. If the quotient is 0, division is not happening. Division is not happening. Division is not happening. But in the question it is mentioned that it is divided by. So obviously division is happening. So q minimum cannot be 0. Under any circumstances, do not take q as 0 if the question is saying that divided by. So n minimum is 9. Smallest integer, largest integer. Next, another question. Find all the integers. Find all the integers less than 40 that leaves a remainder 2 when divided by 7. We have found out the smallest, we have found out the largest. Now we are finding out all the numbers from the smallest to highest. There is a number n. It is divided by 7. Quotient is q. Remainder is 2. So dividend equivalent to divisor into quotient plus remainder. 7q plus 2. What is the n smallest value we got? Smallest value we got it as 9. What is the largest value which we got? Largest value which we got is 37. 37. All the time it is divided by 7. So it will go in steps of 7. 9. Next number is 9 plus 7, 16. Next number is 16 plus 7, 23. Next number is 23 plus 7, 30. Next number is 30 plus 7, 37. I hope it is clear. After doing these smallest, keep on adding it with 7. Why we are adding it with 7? Because every time it is getting divided by. What are the multiples of 7? 7 ones are 7. 7 twos are 14. 7 threes are 21. 7 fours are 28. Every time it is going with a deviation of 7. So 9, 16, 23, 30 and 37. smallest integer we did, largest integer we did, all the variety of integers we did it. I hope the first question is extremely clear to you. 3 variations we did it, extremely useful for all aptitude exams. Now next one, find the greatest 3-digit number that leaves a remainder 4 when divided by 11. Second question, there is a number n. When I am dividing it by 11, I don't know the quotient q, but it is giving a remainder 4. Dividend is n, divisor is 11, quotient is q, remainder is 4. Dividend is nothing but divisor into quotient plus remainder, 11q plus 4. It is a greatest 3-digit number. Greatest 3-digit number. So greatest 3-digit number is 999. 11q plus 4 should be less than 999. 11q is nothing but less than 995. Q is less than 11 nines are 90, 95, 98 point something. 98 point something. I hope it is or 98 point something. Greatest means Q maximum is 98. So answer is 11 into 98 plus 4. 11 8s are 88. I hope it is clear, right? 11 8s are, so you can check it out. What are all the values that you are getting it? 11 9s are 90 point something. Q maximum is 90. So answer is 994. Calculation mistake I did it here. Please, these 90. So Q maximum is 90. 11 into 90 plus 4, 994. This is the greatest 3-digit number. First 2 problems are very easy problems. Slowly I will increase the level of difficulty. Dividend equivalent to divisor into quotient plus remainder. N equivalent to 11q plus 4. 11q is less than 995, 90 point something. Maximum is, Q maximum is 90. 11 into 90 plus 4, 994. Third question. How many integers between 0 and 100 inclusive? Inclusive will make between from. That means you have to include 0 and you have to include 100. Inclusive means it is as equivalent to saying from 0 to 100. There is a number which leaves a remainder of 1. It leaves a remainder of 1 when you divide by 6 with a remainder 1. Dividend equivalent to divisor into quotient plus remainder. So all the numbers lie between 0 less than 6x plus 1 less than. It cannot be equivalent to, because 0 into something plus 1 cannot be 0. 0 into something plus 1 cannot be 100. 0 less than 6x plus 1 less than 100. Method 1. Put minus 1 on both the sides. Minus 1 less than 6x. Subtracting 1 on other sides, which is 99. Dividing it by 6. Minus 1 by 6 less than x less than 99 by 6, which is 0.16 and so on, less than x less than 16. 6 are 96. 16.5. That means x will take from 0 to 16. 0 to 16 totally how many values are there? Totally 17 values are there. There are 17 integers between 0 and 100 inclusive. Between 0 and 100 inclusive. That is nothing but from 0 to 100. 0 less than 6x plus 1 less than 100. Add, subtracting 1 on all the sides. Minus 1 less than 6x less than 99. Divide by 6. Minus 1 by 6 less than x less than 99 by 6. minus 0.16, 0 to 16, which is 17 values. This is the traditional method. Writing down the equation and solving it like this. This is a traditional method. This is a traditional method. I hope it is clear. This is how most of the students will solve it in traditional way. Method 2. Method 2. I want you to get habituated to this method 2. First, there are two questions in this question. There is a number when divided by 6, it leaves a remainder 1. And the condition is 0 less than n less than 100. These are the two conditions. Let us take all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. 97, 98, 99, 100, 96, 91, 92, 93 till 96. What is the number that is possible? These 1 is possible. Are you all with me? 7 is possible. 7 is possible. 13 is possible. Like that, in a set of 6 numbers, in a set of 6 numbers, 6 numbers, 1 number is possible. How many such sets of 6 are there in 100? 100 by 16, 6 is 16 point something. So 16 values, 16 6 sets are there, 96. Another set also there is another value. 16 plus 1 is 17 values. You can write the series and you can solve. How many integers between 0 and 100 leave a remainder of 1 when divided by 6? N is 6a plus 1. 1, 2, 3, 4, 5, 6. Right? 7, 8, 9, 10, 12. In a set of every 6 numbers, in a set of every 6 consecutive numbers, there is 1 value. In a set of every 6 consecutive numbers, there is 1 value. Total in 100, 6 goes 16 times in 100. 16 definite values will be there. In the last set, there is also another value. 16 plus 1 is 17. Total 17 values are there, which will take this form. Are you all with me? This will take this form. How many integers? Just an basic level question. Slowly I will increase the level of difficulty. Another question. How many integers between 200 and 300 inclusive? 200 and 300 inclusive is nothing but from 200 to 300. Inclusive means you have to include 200 and 300. It leaves a remainder of 5 when divided by 8. It leaves a remainder of 5 when divided by 8. Listen carefully. Again, two methods which we will solve. Method 1, which is the traditional method. What is the traditional method? The numbers are from 200 to 300. A number when divided by 8, it gives a remainder 5. Dividend equivalent to divisor into quotient plus remainder. 200 less than 80a plus 5 less than 300. I hope this equation is clear. Subtract 5. 200 minus 5, 195 less than 80a less than 295. Divide by 8. 195 by 8 less than a less than 295 by 8. 8 2s are 16, 35, 8 4s are 32, 24 point something less than a less than 8 3s are 24, 55, 8 6s are 54 point something, 36 point something, 24 point something. I hope it is clear, right? 200. So 195 by 8 less than A less than 295 by 8. 24 point something less than A less than 36. So what are the integers from 24 point something afterwards? 25, 26, 27, 28 and so on up to 36. 25 to 36. Count the number of values, that itself is the answer. Count the number of values, that itself is the answer. I hope this approach is clear. 200 less than 8A plus 5 less than 300. Subtract 5, 195 by 8, 295 by 8. This is one method. Method 2, calculation, finding out the groups method. 25, 36 and some. Now, method 2, counting method. Counting method. What is counting method? The number is of the form, when divided by 8, it gives a remainder 5. It gives a remainder 5. So this value oscillates in between 200 less than or equivalent to n less than or equivalent to 300. 8 25s are 200. But the question is 8 into something plus 5. So 8 into 25 plus 5. So 8 into 25 plus 5, which is the first value, 205. Are you with me? So that means how much we got totally? So from 25 onwards it will start. 25 onwards it will start. 25 and so on up to which value we should stop at? Which value? Suppose if I take 36 plus 5. 836 are 288. 288 plus 5 is 293. 293 plus 8 is 301. So I should stop at 36. Directly I got 25 to 36. 25 to 36 is nothing but total 12 values. How you got 12 values? Higher value minus lower value plus 1. Higher value minus lower value plus 1. Are you with me? Right? Higher minus lower plus 1. Higher minus lower plus 1. Higher minus lower plus 1. See, easily you can also do by using another method. The lowest value is 205. So it is starting with 205. 205, 206 till 300. Till 300. Total how many values are there? 300 minus 205, which is 105. Are you all with me? Which is 300 minus 205, which is 95. 95 plus 1, 96. Total 96 values are there from the lowest value till the highest value. But because it is n equivalent to 8a plus 5, after 8 values only I will get one solution. So 96 by 8 is 12 values. 96 by 8 is 12 values. Again I am explaining method number 2. N is 8a plus 5. 8 25s are 200. So 8 into 25 is 200. 200 plus 5 is 205. 205 is greater than 200. Lowest value I got it as 205. I don't want to count this value. You don't need to count it. From 205 it is starting. It has to go on up to 300. 205 to 300. Total 95 plus 1. Highest value minus lowest value plus 1. Total 96 values are there. Because it is 8a plus 5, 1 is 205. Next will come after steps of 8. Next will come after steps of 8. That means total 96 values are there. In every set of 8, there will be one value which will satisfy. First 8 values, one number will satisfy. Next 8 values, one number will satisfy. Next 8 values, one will satisfy. Like that 96 values, if I take it into a groups of 8, 12 groups will form. Every group one value I will get. So answer is 12 values. Answer is 12 values. Are you all with me? So you don't need to determine the highest value. You can determine the lowest value. Find out the total number of values and divide by how many times the cycle is getting repeated. How many times the cycle is getting repeated. I hope it is clear. Right? Next question. Now, there is a number. There is a number. This number is divided by 48. There is a number which is divided by 48. Quotient is Q. It leaves a remainder 25. It leaves a remainder 25. Dividend is nothing but divisor into quotient plus remainder. The form of the number based upon the first statement is n is 48q plus 25. If the same number is divided by 12, the same number is divided by 12, what will be the remainder? Straightforward question, then I will twist the question. The same number, when it is divided by 12, 48q plus 25 when divided by 12. 48 is perfectly divisible by 12, 25 by 12, 12 2s are 24. Answer for this question is 1. Answer for this question is 1. In every textbook, only this question will be there where the denominator is a factor of the numerator. What if denominator is not a factor? That questions I created it for you. That questions I created it for you. Number when it is divided by 48, dividend equivalent to divisor into quotient plus remainder. So dividend is divisor into quotient plus remainder. 48q plus 25. This 48q plus 25, when you divide by 12, 12 4s are 48, perfectly divisible. 12 2s are 24, remainder is 1. Answer for this question is 1. I hope it is clear. Next one. Another question. Another question. A number when divided by 17 leaves a remainder of 13. A very good question, sir. Please put a star mark. Please put a star mark. There is a number which when divided by 17, there is a number which is divided by 17. Quotient I don't know. Remainder is 13. Dividend is nothing but divisor into quotient plus remainder. N is 17q plus 13. If the same number is divided by 68, the same number I am dividing it by 68. So this is nothing but 17q plus 13 divided by 68. 68. Are you with me? 17q plus 13 divided by 68. Now I will use method 1, then I will use method 2. Method 2. Method 1. Traditional method. Method 1. Traditional method. If q is 0, if q is 0, remainder 1, n is divided by 68 will be 17 into 0, 0. 0 plus 13 is 13. Answer, one value I got 13. If q is 1, if q is 1, 17 plus 13, 30, 30 divided by 68. 30 is not cannot be divided by 68, so answer is 30. If q is 2, 17 2s are 34, 34 plus 13, 47 divided by 68, which is 47. If Q is 3, 17 3s are 51, 51 plus 13, 64 divided by 68 is 64. 64. Are you with me? Q value 0, Q value 1, Q value 2, Q value 3. I got 4 different values. Now check logically. If I put Q value 4, what it will happen? Tell me. 17 4s are 68. 68 divided by 68 is 0. What is the remainder we got? 13. We got 13. Q value 4 is giving back Q value 0 answer. If I put Q value 5, Q value 5, Q value 5 is 17 into 5 plus 13 divided by 68, which is 17 into 4 plus 17 plus 13 divided by 68. 68 divided by 68 is 0. 17 plus 13, Q value 1 we got. 0, 1, 2, 3. Q value 0, Q value 1, Q value 2, Q value 3. All 4 I have given different reminders. From any value greater than 3, the same value is getting repeated. If I put Q value 6, Q6 is nothing but 17 into 6 plus 13. 17 into 4 taken out. Remaining is 17 into 2. I am getting Q value 2. So, how many of them can be the reminders? 13 can be the remainder. 30 can be the remainder. 47 can be the remainder. 64 can be the remainder. Answer for this question is all. Answer for this question is all. Right? It is not. Karthik, please read the question properly. It says that which of the following can be the reminders? Can be means may or may not be. It is not telling the question which of the following shall be the reminders. Suppose a very good question that you have asked, right? I need to explain here can be. Suppose Q0, Q1, Q2, Q3. This example is for Karthik. Suppose you went to an examination hall. A paper is given to you with some questions. You went to the examination hall. You sat in the examination hall. You did not attempted any question in the examination hall. You attended the exam, but you did not attempted any question in the examination hall. In the last 1 minute, when the invigilator says time up, you just clicked on submit button and left the examination hall. Now my question to you, did you attempted the paper? You attempted the paper. Did you attempted any questions in that paper? You did not attempted any questions in the paper, but you attended the exam and you clicked on submit button. I hope this statement is extremely clear to you. If he says which of the following can be the reminders, maybe the division is not happening and you are getting the same numerator as the remainder. So that could also be a possibility. I repeat, could be a possibility, not necessarily must be a possibility. Suppose one more example. In a question there are 4 options. In a question there are 4 options. In how many ways can you solve a question? You attempted option A, or you attempted option B, you attempted option C, you attempted option D. Generally, a teacher who does not have a good understanding of mathematics, he will say that there is a 25% probability to answer a question. But I am saying that why 25%? Either A or B or C or D, either 1 out of 4. I am saying 25% is incorrect, 20% is right. Either you can tick mark A, or you can tick mark B, or tick mark C, or tick mark D, or you decided that I will not tick mark any of the options. Not tick marking is also one of the way of answering a question. That means in case if you are a 21 or 22 and you are not married, you should say that I am married with none instead of saying that you are single. That's a mathematical way of expressing your bachelorhood. You are married with none. You are married with none is equivalent to semantically that you are single. I hope it is clear. I hope it is clear. Right? Sai Karthik, I hope these two has given you enough understanding of this question. Right? Rupa, my way of teaching is when I am teaching subject, I am only into subject. Anything which is of an individual help, please ask me at the end of the class. On the PPT you can see a number. You can WhatsApp your doubt to that number. After the class we will discuss. Please allow me to discuss only the subject. Not even 1 minute I want to waste my students' time sitting and giving their personal time to me, and I am also giving my personal time to you. Please do not do time pass with me when I am on my job. A, B, C, D. Rupa, please WhatsApp. At the end of the class we will discuss. So answer is all. But should I do all this? I don't need to do it. Now direct answer how to do. Method 2. Anil Nair's way of solving. How I will solve this question, which I can solve it in 10 seconds. 10 seconds is the maximum time. 10 seconds is the maximum time that I need to solve this kind of questions. Now see, a number when divided by 17, quotient is Q, remainder is 13. So dividend equivalent to divisor into quotient plus remainder. Find the remainder when it is divided, reminders when it is divided by 68. 17 into Q plus 13 divided by 68. Now tell me which multiple of 17 will be divisible by 68. What should be the lowest value of Q that will make 17Q divisible by 68? Q value lowest is 4. Am I right? Take all the values less than 4. Q has to be less than 4. Q can be 0, 1, 2, 3. Answer is 4 values I will get. Answer is 4 values I will get. Again I am repeating the question. Root cause of the problem. 17 into Q plus 13 by 68. No, you don't need to find out any values. What is the value of Q that will make this number get divided by this number? Or in other words, denominator is 68. 17 goes how many times in 68? 4 times. So Q will take all the whole number values less than 4. Q is 0, Q is 1, Q is 2, Q is 3. 4 values it will take. Simple. From 4 onwards, the cyclicity will get repeated. Question will be, which of the following can be the reminders, or how many distinct reminders are possible? How many distinct reminders are possible? How many distinct reminders are possible? I hope the idea is clear. Now, any question, generally in our local Indian textbooks, reverse will be there. This will be 68, this will be 17. So directly they will divide, this itself will be the answer. R.S. Agarwal, very narrow-minded way of asking the question. I hope it is clear. Now, all the other questions, cakewalk it is. A number when divided by 30 leaves a remainder of 20. A number when divided by 30, quotient is Q, remainder is 20. Dividend equivalent to divisor into quotient plus remainder. 30 into Q plus 20. What are all the remainders when n is divided by 120? N is divided by 120. 30 into Q plus 20 divided by 120. What is the multiple of 30 that goes up to 120? 4 times. Q should take less than 4. Q0, Q1, Q2 and Q3. Q0 can be the remainders. One remainder is 20. Q1, 30 plus 20 is 50. Q2, 30 plus 30 into 2, 60. 60 plus 20, 80. Another remainder. 33s are 90. 90 plus 20, 110. You don't need to do all this. First Q value 0, 20. Keep on adding 30. Keep on adding 30. 20, 50, 80, 110. How many values? Which of the following can be the remainders? 20 can be the remainders, 50 can be the remainder, 80 can be the remainder, and 110 can be the remainder. 110 can be the remainder. Right? I hope it is clear. Q value is less than 4. Q0, Q1, Q2, Q3. Right? You don't need to find out. Take Q value 0, keep on adding 30 because it is getting divided by 30. Basic level to the advanced level from a particular topic. I am only discussing this one because in the morning 7 o'clock session, we discussed a rule. Dividend is a divisor into quotient plus remainder. I felt that I only taught you that concept. I did not told you the application part of it. Right? So that's the reason I started developing all these questions. I hope the idea is clear. Next one. You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.